Right. So the topics that we are going to cover in today's class are number one, photoelectric effect, because like one of you had requested to take this topic, especially for unit conversions. That is where you are probably facing problem while taking a numerical on this. We'll take a couple of problems on Compton effect too. Okay. And after this, we will directly jump on the popular, all the three boxes, people, 1D, 2D, and 3D boxes. Okay. And then we will take 1D, 2D, and 3D harmonic oscillator. So these were the topics that you guys had wanted me to take in today's class. If there is something else you want me to add, that you can like request at the end of this class. First, let's complete these topics. Okay. Chalo. Let's get started, people. Photoelectric effect. I will directly take a numerical on this. Okay. I've already luckily this time I was able to find some time to type some questions. So here's one. Okay. Let's. It's a good question, people. So the question is, the figure shows the results obtained during a photoelectric effect experiment where the stopping potential is plotted against the frequency of incident radiation. And they're asking you the work function. How do you approach this problem, first of all? It's simple. It's a straight line. You need to find an equation which relates y-axis and x-axis. Who is along y-axis? People, stopping potential is along y-axis. Who is along x-axis? Frequency. Frequency of what? They have mentioned frequency of incident radiation. So you need to first derive an equation of stopping potential and incident frequency, and then using which you can find work function. So for an example, what is it that you know? That the incident energy, people, the incident energy, first, it is used to overcome the work function. I hope you remember. You denote work function by phi or W, whatever. So first, the incident energy is used to overcome the barrier potential, or you can say work function. And the remaining energy is transferred to the electron in the form of kinetic energy. Any questions in this equation? Incident energy is divided as work function, and the remaining will be transferred as kinetic energy. So incident energy can be written as h into incident frequency, h nu. What is work function, people? It is let's keep it just work function phi itself. Now let's not change it. Let's keep it phi because we want to find work function. No? So let's keep it that way. But what is kinetic energy? E into V. Yes, perfect. That's it. So I think we are able to get an equation here. You know, we need y-s stopping potential and x-s frequency. And this is the equation of a straight line. What is the equation of this straight line usually? How do we write this? Y equals to mx plus c. No? Y equals to mx plus c. This is the equation of a straight line where c is the intercept. Where c is the intercept, people. So let's write it in that form. Okay. So h nu I minus phi. This is E into Vs, or I can say h upon E into nu I minus phi upon E. This is Vs, or I can say Vs, which is my y coordinate. Okay, is equals to h upon E into nu I minus phi upon E. This is it. That's our answer, because this is y coordinate, slope, x, which is incident frequency, stopping potential is y, people, and x-axis is incident frequency, as you can clearly see, and the intercept. Sir, intercept is negative here. And look at the intercept is negative now. Where is this intersecting, people, to the y-axis? It is intersecting the y-axis negative, which is perfect. So if you want, you can write minus c. Purposely, you can write minus c because you know that the intercept is negative now. Have a look. Is that clear, people? Okay, so that's it. It means that whatever is the value of this intercept, people. See, if you want, you can write plus c, doesn't matter. So what is the value of intercept right now in the diagram? It's minus 2. Minus 2 volts. Okay, so value of c is minus 2. But comparing, what do you get? Minus phi by e. Minus phi by e is minus 2. So that's it. Phi is 2e, people. Work function is 2e. That's the answer. Answer is option C, 2 electron volts. That's it. Make a note. It was an interesting question, and hence I took this one. So this is in volts. Okay, this is in volts. So this becomes 2 electron volts, people. Okay. Hello, have a look. Stopping potential it is in volts. So this is -2 volts. Okay.
Yes, sir.
Chalo, let's proceed. Let me know if you have any questions. Next, let's take another equation, another question on this here. So they have given us an argon ion laser produces monochromatic light with a wavelength of 514 nanometer. Okay, so they have given us wavelength which is 514 nanometer. So what is our energy? Energy is hc by lambda. I had given you a shortcut value of hc2 by heart, if you remember, in terms of electron volt nanometer. What is that value, people?
12,400 इलेक्ट्रॉन वोल्ट एंगस्ट्रॉम.
Okay, so, yes, 12,400 electron volt angstrom, or you can say 1240 electron volt nanometer. So right now lambda is in nanometer, no? So let's use this directly. 1240 electron volt nanometer. This is a time saving thing. Like if you are able to by heart this, it will save a lot of your time in exam. Otherwise, if you want, you can go ahead and substitute 6.63 into 10 raised to minus 34 for H, 3 into 10 raised to 8 for C, but you will get every answer in terms of joules. Usually we keep everything in electron volts because it helps us in most of the problem. Okay, but anyway, it's always your call. Okay, so this is 514 nanometer. So what do we see? 9 nanometer gets cancelled, and we have got 1240 upon 514. Let's calculate this. Calculator. 1240 divided by 514. So that's 2.412. This is 2.412 electron volts, people. Okay, we can convert this in joule if you want. So what is 1 electron volt? It's 1.6 into 10 raised to minus 19 joules. So this becomes 2.142 into 1.6 into 10 raised to minus 19 joules. So this becomes into 1.6, and I'm getting 3.8599, which is 3.86 roughly, into 10 raised to minus 19 joules. This is energy. They have given us power is 1 watt, people. Power is 1 watt. Power is basically energy per unit time. Power is energy per unit time. Okay. But when you say energy, energy of what? Energy of like total energy per unit time, basically. I can say power is work done per unit time, or you can say total energy per unit time. Either way, work upon time, total energy upon time. Can I say total energy is number of photons into energy of each photon upon time? I hope this is fine.
Yes, sir.
Bas, so what is it that they are asking? Bolo. Any questions?
No questions, sir.
Okay, so that's it. So what is it that they are asking us? They are asking us at what rate the laser is emitting photon. It means they are asking you number of photons emitted per unit time. What is the meaning of it? At what rate the laser is emitting photon? It means number of photons per unit time. Number of photons per unit time. That's it. So they are asking you n by t basically, and now you know the answer. So power is ne by t. So we have got n by t, which is nothing but power by e. Power is 1. They have given us. Energy is 3.86 into 10 raised to minus 19. So your answer 1 upon 3.86. Let's calculate. So that's 0.256, which is 0.26 into 10 raised to 19. Or I can say 2.6 into 10 raised to 18. Answer is option B, everyone. I hope this is clear. Tell me if not. Ask me if you have any questions. Do not hesitate. Okay.
Yes.
Chalo, next. Proceeding ahead. I'm not sure. Do we have another question on this? Yes, we have another question. I think this was one of the IISc question only. Given that the work function of a metal is 5 electron volts, so they have given us work function 5 electron volts, and the photons of 9 electron volts are incident on it. So that's energy, incident energy, which is 9 electron volts. So the maximum velocity of emitted electrons is approximately. This is a time pass question actually. I mean, okay. So what is incident energy? That's work function plus kinetic energy. So we have got 9 electron volts. This is equals to 5 electron volt plus kinetic energy. So we have got 4 electron volt is kinetic energy. But what is kinetic energy? Half mv square. This is 4 electron volt. So V will be equals to 2 into 4 electron volt upon mass under root. Now listen, just in exam now, take care of one thing. Usually we always talk about photoelectric effect, but I have seen there are some hypothetical questions where they say, what if some another random particle, they may just give a random particle and they will tell you that instead of electron, this particle was emitted. So in that case, you have to take care of the mass. Do not substitute mass of electron. Just see that which particle is emitted. Okay. So right now, obviously electron is emitted, so you will substitute mass of electron only. So what is the value here? 4 into 2 is 8. Electron volt is 1.6 into 10 raised to minus 19. And what is mass of electron? 9.1 into 10 raised to minus 31. And this is time pass question only. Okay. So, but actually, I have taken these questions only because somebody had said that there are problems in unit conversion. I hope these little things is helping you, and I'm not sure if there is some specific question which you have come across where there are a lot of unit conversion is happening. Maybe you can share me, you can tell me that question, and we can take that also in class. Okay, but this is it right now. So what do we have? 8 into 1.6 divided by 9.1. Okay, yes, so that's 1.40. So under root of 1.40, we have got 1.18. 1.18 into 10 raised to minus 31 goes about 10 raised to plus 31. 31 minus 19 is 12. Under root of 10 raised to 12 is 10 raised to 6. So 1.18 into 10 raised to 6, answer is option A. 1.2 into 10 raised to 6. Make a note, please.
Yes, sir.
Sure. Next. Just take care with the calculator. See, right now, so I'm doing this using phone's calculator. Practice these kind of calculation using the JAM calculator too. I have told you that we have an application. Either use that application, or you can just go through the internet, find the mock test link of the IIT Roorkee website, and there you can use their original calculator and practice it with the mouse too, like how to click using mouse. Using thumbs and fingers you all have practiced, but remember in exam you have to use mouse actually. Okay, so just take care of that too. Next, so these were questions related to photoelectric effect. If there is a specific question you want me to take from photoelectric, if you have come across, you can tell me now, or I will proceed with Compton. Okay, chalo, next. So let's take a couple of questions on Compton now. So here's one question. In a Compton experiment, the ultraviolet light of wavelength 2000 angstrom is scattered from an electron at rest. What should be the minimum resolving power of an optical instrument to measure the Compton shift? So this is a combination of Compton effect along with your optics. In optics, you have learned resolving power. Okay. So the major formula that you are going to use is the general formula of resolving power, but mostly you have used it for gratings. Okay. Can you just tell me an approach, how to approach this question? Any guesses? How to find resolving power? How this is connected to Compton experiment? Which formula of resolving power do you know? What is the most?
Del lambda by lambda. So
it's other way around. You are correct, but it's other way around. It's lambda upon delta lambda. Okay. What you said is the answer for limit of resolution. Resolving power.
Okay, yes, sir. Yes.
And what you said is for limit of resolution, that is delta lambda upon lambda. Okay. See, the best way to remember is limit of resolution will be a small quantity. So obviously it will be changed upon the original, which is heavy. But resolving power will be a large quantity. Okay, so obviously it will be the original wavelength upon the change. That's how you can always remember it. LOR is limit of resolution. Okay, so now you know what you are supposed to do. What is the Compton Shivka formula, people? We know delta lambda is lambda C into 1 minus cos phi. That's it. So delta lambda is given by lambda C. If you remember, what is lambda C, people? H upon
0.024.
Yes, and it is 0.024 angstroms. Take care of that. So this is 0.024 angstroms into 1 minus cos. What is the angle? 90 degree they have mentioned. So cos 90 is 0. So this is just 0.024 angstroms. So your answer is simple, not limit of resolution. You want to calculate resolving power. That's lambda, which is 2000 angstroms upon 0.024 angstroms. Angstroms and angstroms get cancelled. We have got, let's calculate, 2000 divided by 0.024. So that's 83,333, like around 80,000 basically. So see, I'm getting 83,333. The reason is obviously, remember, this 0.024 is a very approximated value. Okay, so you have to mark the nearest answer to this.
सर लैम्डा एवरेज वैल्यू लेते हैं सर.
हाँ, pardon?
एवरेज वैल्यू लेते हैं सर लैम्डा की, लैम्डा 1 + लैम्डा 2/2.
But honey, वो तो lambda के लिए ना, like यहाँ पर for this lambda, the thing is they have not given us the value of that lambda. हाँ, but
लैम्डा आ तो गया
अच्छा,
सर.
okay. ठीक है, let's try that. Okay, yes, good observation, absolutely. But ठीक है, चलो, let's do that too. Very good. Yes, absolutely. So lambda dash minus lambda is 0.024. But let's see if using that we are getting the correct answer or not. So, but anyway, our answer will still be correct. But let's try this. So lambda dash will be equal to lambda plus 0.024. So this will be, what is the original lambda? 2000. So 2000 plus 0.024. Okay. So this becomes.
Excuse me, sir.
Yes, pardon.
Sir, how can we think electron to be moving with the velocity at a speed of light? Because in that case, the relativistic mass will become,
No. Here electron
infinity,
is not moving. Here electron is not moving with the speed of light.
or it is photon.
Photon.
Yes.
Photon is moving with speed of light. Yes. Okay. So yes. So lambda dash is lambda plus 0.024. So that's 2000 plus 0.024. So lambda dash becomes 2000.024. But as you see, there is no point on taking average. Okay. But okay, let's take an average and let's see. So like when you talk about resolving power, and in resolving power, when you talk about lambda upon delta lambda, so this is actually average lambda, absolutely. So let's calculate the average lambda. So that's lambda plus lambda dash by 2. So that will be 2000 plus 2000.024 by 2. That would be 2000.012. And now you can calculate resolving power. So that's 2000.012 upon 0.024. But I'm not sure how exactly this will help us. Let's try. 2000.012. I said 12 now. 012 divided by 0.024. I'm still getting 83,333. So it's not that great. The only reason that we are not getting an accurate answer is because the value of lambda c that we have by hearted, 0.024, it's an approximated value. If you will calculate h upon m naught c properly, it will be 0.023 something, which we had approximated it to 0.024. But the nearest answer is option C. So that is the answer that we will. Or I think it was 0.0242 rather. I remember the third digit now. It was 0.0242. Ask me if you have any questions.
सर मैंने वो फॉर्मूला मतलब समझ नहीं आया.
अच्छा, just a second. I will also check this 0.0. Okay, leave it. छोड़ो. हाँ, कहाँ पे? Which one? This?
नहीं सर, फर्स्ट हाँ पहले वाला ये जो दोनों में डिफरेंस क्या है मतलब?
नहीं. Okay. So the thing is, suppose if I give you two objects, one object and two objects. Limit of resolutions are of two types. One is angular limit, other is linear limit. Okay. So for an example, what should be the distance, minimum distance between them, such that they are just resolved from your eye? This linear arc distance. Like suppose you need to go far, just keep on going away. If you keep on going away, and what will happen? Eventually, there will come a point where what will happen? These two will merge with each other, and you will not be able to differentiate between them. So when like the distance at which this just happens, so at that position, whatever is the linear distance between them, that's your limit of resolution. And whatever is the angular distance, that becomes your angular limit of resolution. So one is linear limit, other is known as angular limit, and the reciprocal of it, that is known as resolving power. Okay, so how do we calculate limit of resolution? Delta lambda of lambda, and resolving power. This is resolving power. It is 1 upon limit of resolution. So it's reciprocal of this. It means it becomes lambda upon delta. Clear?
Yes, sir. Yes, sir.
So in question they have asked you to find resolving power, है ना? So we are using this formula. ठीक है? चलो next.
सर काइनेटिक एनर्जी ऑफ रिकॉइलिंग कैसे फाइंड करेंगे?
Kinetic
एनर्जी ऑफ रिकॉइलिंग इन कॉम्पटन इफेक्ट.
Recoiling in Compton effect. I think there is a very pathetic formula for it which you have to by heart. But I mean, you don't have to by heart. But in one of the JAM paper, in subjective like 2009 or whatever, they had asked that thing to derive. But I have that formula which I will just give you. But I don't suggest you to by heart that. But I have that formula. Just a minute. So this one is different and. This is not the one. Delta lambda. Okay, derive the relation. That's quad 5 by 2. That's different. Kinetic energy of recoiling electron. See, there is a derivation for this, but obviously we don't need to go to the. I mean, see, it's not difficult to derive this, to be honest. What would be the incident energy? H nu. What is the final energy? H nu dash. Hello. What will be kinetic energy? H nu minus H nu dash. But we have to convert this in the form of lambda, cross multiply, apply the formula of Compton shift. We already know the formula. After doing that, you will end up getting this E into lambda C. Just a minute, I need to cuff it out. Okay, E into lambda C into 1 minus cos phi, the whole upon lambda plus lambda C into 1 minus cos phi. So this we can derive. You just have to convert this mu in the form of lambda and lambda dash and then apply the formula of Compton shift that we know. That's it.
Sir, phi is angle of incidence.
Phi is no, not the angle of incidence. Phi is the angle of scattering, na?
Scattering electron.
Angle of scattering, okay? So take care of that. And also, and listen, no, not scattering of electron. Phi is angle of scattering of photon. Phi is angle of scattering of photon. Angle of scattering of photon. So you don't have to by heart this thing. It's derivable, okay? So you just remember this concept, and then you can always derive it. Okay? Chalo, next. Any other questions, people, related to Compton? I mean, I have to take another numerical, but still. Chalo, let's take another question. So this one is a good question where I think everything I have tried to cover up. So the question is, X-rays of wavelength lambda 0.612 angstroms are scattered by free electrons, basically Compton collision. The scattered radiation is at an angle of 90 degrees once again. Then, okay, Compton shift is. So Compton shift, obviously we know the answer. It is going to be lambda C into 1 minus cos phi. Phi is again 90 degree. So obviously it will be again equals to lambda C into 1 minus cos 90. Cos 90 is 0. So this is just lambda C, which is 0.024 angstroms. Okay. So Compton shift is 0.246. That's wrong. No? It is 0.024. They have mentioned 0.246 angstroms, which is wrong. Next. Wavelength of the scattered radiation. So that's lambda dash minus lambda, which is 0.024. So lambda dash is lambda plus 0.024. So this will be 0.612 plus 0.024. So we have got 0.636. B is correct. Okay. Change in kinetic energy possessed by photon. How do we calculate this?
Change in wavelength.
Change in not change in wavelength, but yes, we need change in kinetic energy.
H multiply करेंगे.
So incident energy is going to be equal to incident energy is which energy? It is the kinetic energy of photon only, na? Incident energy is the kinetic energy of photon only. So this is nothing but kinetic energy of photon. Okay, because photon does not have any potential energy, does not have any mass. So that's kinetic energy of photon by default. So that is hc by lambda. Okay, so we need the answer in terms of electron volts. So we know what we are supposed to do here. We can write 12,400 electron volt angstroms upon what is the original lambda. That's 0.612. Next, and the final energy, that's again kinetic energy of photon only, but the final kinetic energy of photon. Okay, so that's nothing but hc by lambda dash. So that's again 12,400 electron volt angstroms upon what is lambda dash? 0.636. Let's calculate. So we just need to calculate that difference. Okay, obviously there will be loss. Okay, so it will be initial minus final. There will be loss, people, so it will be initial minus final. Minus 1 divided by 0.636. So I'm getting 0.0616 into 12,400. Okay, so we are getting 764 electron volt. Do we have an answer? A close answer, 772. Okay, what do you think? Should we mark that or not? But I think it should be good. Like, maybe they should mention change in energy is nearly this much. But okay, answer should be good, 764 electron volt. The next is kinetic energy imparted to the electron. What is the kinetic energy imparted to the electron? So that would
Loss
be
in kinetic energy of photon.
obviously same answer. Whatever is the loss of kinetic energy of photon, same is the kinetic energy imparted to the electron. So same answer, option D. Great, answer is BCD. Okay. However, in JAM, this would have been a bit debatable because they should have mentioned it's nearly, because I don't think we have done any calculation error. Maybe like depending upon the value of lambda c, things would have changed, but it's okay. Nearly word should have been there here. Okay. Any questions, anyone? Please ask. So whatever is the loss of kinetic energy of the photon, the same energy is transferred to the electron. Law of conservation of energy, people. So that's all about photoelectric effect and Compton effect. Is there anything else you want me to cover from the first chapter? And otherwise, we'll directly jump to boxes and harmonic oscillators. Chalo, next, okay. Proceeding ahead. So what exactly you guys wanted me to do in this? I think you wanted me to take you through the formula of probably of each of them and some random problems here and there. See, unnecessarily we are not going to stretch the class, okay? Because I respect the time limitation that we have and you need good revision too. So I will just go through the formulae once, okay? Okay. Somebody's commenting something? No? Okay. Sure. So to start with, 1D box, people. 1D box. So in 1D box, the wave function is given by psi n, and it is root of 2 by L sine n pi x by L. But you need to remember that n starts from 1 here, n here cannot take the value 0. Okay. Energy is given by n square pi square h square upon 2 ml square. And this is always non-degenerate. It is always non-degenerate. It means every state, like every energy eigenvalue has only one corresponding state. There are not multiple states with the same eigenvalue. There are not multiple states. There are not multiple states with same energy value. With same energy value. Clear? I hope you recall this. Ask me if you have any questions.
Sir,
And remember,
non-degeneracy.
non-degeneracy. Pardon, non-degeneracy matlab?
Non-degenerate means degeneracy 1.
Yes. So when you say non-degeneracy, it means degeneracy is 1, absolutely. Degeneracy is 1, either way. Okay, next. So proceeding ahead. So like on this, if we just create a random question that let's say I have got 7 electrons and they are asking you find that minimum energy, something like that, then you know what you are supposed to do. Electrons are fermions. So 2 electrons can be in the same state, like so we have got 2 electrons in the ground state. then we will have 2 electrons in the first excited state, then we will have 2 electrons in the second excited state, and then we will have 1 electron in the third excited state. That's it. 7 electrons, 2 electrons can be in one state when it comes to electrons. Okay? So our energy becomes absolutely 2 are in ground, so 2 E naught, 2 are in first, so this is 2, not E naught, here we have E1, sorry. 0 does not exist. So 2 E1, then 2 are in first excited. Remember, this is n equals to 1, this is n equals to 2, n equals to 3, n equals to 4. Ground state means first level. First excited state means second level. Second excited state is third level, and third excited state is fourth level. So pth excited state is actually p plus 1 level, people. Or you can say the value of n is p plus 1 basically when you talk about pth excited state. So like first excited state has got 1 plus 1, which is 2. Okay, this is first excited state. This is second excited state. This is third excited state. Please tell me if you have any confusion, and this is ground state. Okay, so energy is 2E1 plus 2E2. Then there are 2 electrons in E3, and then we have got 1 electron in E4. That's it. What is En? En is, as we know, n square pi square h cut square upon 2 ml square. Okay, we can write this as E1, which is 1 square pi square h cut square upon 2 ml square, which is just pi square h cut square upon 2 ml. So in general, can I say that En is n square into E1? Because who is pi square h cut square upon 2 ml square? E1. So what will be even En? N square into E1, people. I hope this is clear. So 2E1 plus 2 into En is n square E1. So E2 would be 2 square E1. So 2 into E3 will be 3 square E1. And 1 into E4 will be 4 square E1. So what's our answer, everyone? 2E1 plus 2 square is 4, 4 2s are 8, 8 E1 plus 3 square is 9, 9 2s are 18, 18 E1 plus 4 square is 16, 16 E1. So our answer is 8, 10, 28 and 44. 44 E1 is the answer. Is that clear, everyone?
Yes, sir.
Please ask me if you have any questions here. Don't hesitate. Next. And then instead of 7 electrons, if they would have mentioned that, by the way, just another thing. So when you write 44 E1, if suppose it's a numerical answer type, then obviously you need to write the value of E1. So what is the value of E1? Pi square h cut square upon 2 ml square. So they will give you the value of length. They will give you the value of h or h cut. We already know the value of h or h cut. H is obviously, we know, 6.63 into 10 raised to minus 34. H cut is h upon 2 pi. Have you by hearted the value of h cut too, by the way? It is 1.05, just by hearted.
Yes.
Into 10 raised to minus 34. Okay. So you can directly substitute pi square h cut square upon 2 ml square, and just take care in exam regarding the mass. If it is electrons, then you will use this thing, 9.1 into 10 raised to minus 31. But if it is something else, then you will use the respective mass. Okay, take care of the mass part. Okay, next. Then obviously, you know, if suppose I would have given you 3 spinless fermions, so in that case, at the end it's fermions. So we can maximum we could have had is 2 electrons in the same state, 2. But because these are spinless, okay, now only 1 will remain. So 1 electron will be here, 1 will be here, and 1 will be here. That's it. Because these are spinless but fermions, they are fermions. So when it comes to fermions, no 2 same electrons state can be in the same state. Basically, whatever electrons you have, they must be differentiable. See, here they were differentiable now. One was upspin, other is downspin. So they must be differentiable. Pauli's exclusion principle tells you that 2 electrons, as far as they are differentiable, they can be in the same state. But if they are not differentiable, then obviously only 1 electron will be in one state. So we have got 3 electrons, 3 states. Our answer is that's it. Minimum possible energy that the system can have is 1 electron is in ground state, another electron is in first excited state and another electron is in second excited state. Second excited state is third level. Huh? So our answer is E1 plus E2 plus E3. So this is E1 plus 2 square E1 plus 3 square E1. So we have got 9, 13 and 14 E1. And obviously, if we had bosons, if I would have given you 4 bosons, then all of them can be in the ground state. You know that already. You know? So all the bosons can be in the ground state. For bosons, there are no limitations. There are no conditions. So all the bosons can be in the ground state. So if I've got 4 bosons, 4 will be in the ground. Minimum possible energy will be 4 equal. That's it. Okay. Next. Another important thing here is, if suppose they give you wave function, people, and wave function is given in the form of something like 1 upon root 5, okay, and 1 upon root 5 L maybe, you know, sine 2 pi x by L, and then you have got another wave function, let's say 1 upon, or just checking out, hang on. Okay, another 1 upon root 5. Okay, another 1 upon root 5L, or let's say root 3L maybe. I'm just creating random problems. So let me check. 2, no, I will make it. Okay, 1 upon root 5L only. Let's say sine 3 pi x by L. And they have given you its 1D box. So first of all, we need to convert this in the form of linear combination. Like you need to write this in the form of C1 psi 1 plus C2 psi 2 plus C3 psi 3. You need to write this in that form. Okay. So let's do that first. So how do we write the value of psi n, people? Psi n is root of 2 by L sine n pi x by L.
Multiply and divide by root 2 by L.
Yes. So multiply and divide by root 2 by L. Let's do that. So we have got 1 upon root 5L. So I will just multiply by root L by 2 and root 2 by L. Okay. And I have got sine 2 pi x by L.
root to करने से L तो पहले से ही है.
Like it's either way. Like I find this more comfortable. But if you are able to notice कि L पहले से है, multiply and divide by root 2 only, that's also fine. So okay. So root L by 2 and root 2 by L once again. I have got sine 3 pi x by L. Okay. So now as we see here, first of all, root L and root L gets cancelled, and we have got 1 upon root 10. We have got 1 upon root 10. Root of 2 by L sine 2 pi x by L, this becomes psi 2, because root of 2 by L sine n pi x by L is psi n. Similarly, L and L gets cancelled. I've got again 1 upon root 10. Okay. Root of 2 by L sine 3 pi x by L, this becomes psi 3. So we have got, people, C2 psi 2 plus C3 psi 3. Okay. So where C2 is 1 upon root 10 and C3 is 1 upon root 10.
Yes, sir.
Okay. Also, is this normalized?
No.
No, sir.
How do we check the normalization condition?
C1 square plus C2 square.
Yes. So right now we have got C2 and C3. So I'll just write C2 square plus C3 square. And we have got 1 upon root 10 square plus 1 upon root 10 square. That's 1 by 10 plus 1 by 10. So this is 2 by 10 and this is 1 by 5. So since this is not equals to 1, this is not normalized. Okay. So if I would have asked you, what is the probability? What is the probability that the final energy eigenvalue is E1? What is the answer?
C1 square E1.
But answer is 0 here, because psi1 doesn't exist.
Yes, sir.
Psi1 doesn't exist here. So probability that the energy will be E1 is 0. But if I would have mentioned probability of finding energy E2, then what is the answer?
C2 square side E2 by ये वाला 1 by 5.
Basically you can just say C2 square upon the total C2 square plus C3 square. Okay. So what is C2 square? That's 1 by root 10 square, which is 1 by 10, and C2 square plus C3 square, that's 1 by 5, So this is 5 by 10, which is 1 by 2. Okay. And similarly, probability of finding energy E3 is similarly 1 by 2 once again. Like formula here will be C3 square upon C2 square plus C3 square. Okay. Please tell me if you have any questions. Like in denominator, technically you have C1, C2, C3, C4, C5, you have everything in the denominator. But C1, C4 doesn't exist. So we have just written C2, C3. Okay. And also remember that right now the values are real. If they are complex, then you have to take care that whatever, like for example, if you write C3 square, it should actually be written as C3 star C3 in that case. So in case of complex values, just take care of that. Okay, people. Chalo, next. And if I would have asked in the same question, find the average energy, then how do we find the average energy?
C1 square E1 plus C2 square E2 by C1 square C2 square.
Okay. Or either way, or you can directly write probability of energy in E1 into energy in E1. This one is 0 anyway. So we have got probability of energy in E2 into energy in E2 plus probability of energy in E3 into energy of E3. Okay. Probability, you know how to find energy. Probability, you know how to find energy. Simple. So probability in the first case is half. Energy is basically 2 square E1. We know that. N square E1, we already know that. Probability of energy E3 is also half. What is energy of E3? It's N square E1 again. So this is again 3 square E1. Okay. So average energy would be 4E1 by 2. That's 2E1 plus 9E1 by 2, which is 4.5 E1. So our average energy would be 6.5 E1. Clear, everybody? Do you have any questions in this much so far?
Sir, average and expectation दोनों same है ना?
Same. Yes, same. Sure.
Okay, sir.
Okay. Now, so 2D box. So in 2D box, the wave function has two quantum numbers nx and y. It has got two variables x, y. It can be written as psi nx into x, product of psi ny into y. So psi nx is root of 2 by L sine n pi x by L. Psi ny, that's again root of 2 by L sine n pi y by L. But there are a couple of important things to note here. That is, n is actually nx. Here n is actually ny. L is actually lx, and ly, ly. So this is a general formula. If it's a 2D box where the lengths will be equal, which usually they will be. If the lengths become equal, in that case, lx, if lx and ly, they become equal to L, then the value of psi nx and y would be root of 2 by L into root of 2 by L. That becomes just 2 by L sine of nx pi x by L into sine of ny pi y by L, if Lx and Ly becomes equal. Next. Let's talk about energy. So energy of nx and y. So energy is a scalar quantity. It is directly addition enx plus any. So that is nx square pi square h cut square upon 2m lx square plus ny square pi square h cut square upon 2m ly square. If Lx and Ly again becomes equal, then the value of energy E nx and y, this becomes equals to, you can take pi square h cut square upon 2 ml square, pi square h cut square upon 2 ml square common, pi square h cut square upon 2 ml square common, we will be left with nx square plus ny square, which is further written as n square pi square h cut square upon 2 ml square. But very important thing to remember now is that this n is not a quantum number. It is just a random number. Nx is a quantum number. Okay, nx is a quantum number. Ny is a quantum number. But n is not a quantum number because n square is nx square plus ny square. And now degeneracy can exist. Like 0 square plus 1 square and 1 square plus 0 square can give us same value. So now degeneracy can exist. So two different states like psi 1 0, the energy eigenvalue of this, and psi 0 1, the energy eigenvalue of this, both of them will be same because nx and ny are different. The states are different, but
सर
energy
जीरो
will
अलाउ
be
नहीं है ना?
हाँ,
जीरो
zero नहीं
अलाउ नहीं है
रहेगा,
ना?
zero नहीं रहेगा. Zero is only in harmonic oscillators. ठीक है. Boxes में there is no zero. Harmonic oscillators can have zero value, but energy doesn't become zero there. Only the quantum number becomes zero. Energy still becomes non-zero because it's n plus half h cut omega. So if n becomes zero, even then ground state has energy. Basically, ground state energy is never zero. Never. It is never zero. Ground state energy. Even the quantum number can become zero in harmonic oscillators, ground state energy is still non-zero. ठीक है?
Yes, sir.
So I think now I don't know what kind of questions should we take on this thinking. Let's randomly take maybe. So suppose I have got 9 electrons, okay, but now I have got 2D box. Okay, so we have to take care how exactly we used to do these questions. So first of all, ground. Okay, let's talk about n square. It is nx square plus ny square. Okay, one combination is 1 comma 1. Sorry, 0 is not allowed now. Acha, that's what you were saying. So this was just a random example. Huh? Sorry. I just wanted to explain degeneracy, but yes, 0 is not allowed. Absolutely, it's not allowed. In this boxes, it is not allowed. Yes. So minimum value is 1 1. So that's non-degenerate. 1 square plus 1 square. Okay. So I can say n square value is 1. This is our ground state. Ground state. Okay. Next, thinking of. So I've got 2 electrons, and after that I can have 1 2 and 2 1. I can have 1 2 and 2 1. They both will have same value now. So what will be the value of n square, people? 1 square plus 2 square, that's 5 basically. N square will be 5. So that's next combination. So I can have 1 2 and I can have 2 1. So 1 2 state can have 2
Sir,
electrons.
ground state में
हाँ.
सर ग्राउंड स्टेट में nx ny 1 1 है ना, तो n स्क्वायर इक्वल टू 2 आना चाहिए.
हाँ, yes, absolutely. Absolutely. So yes, so n square is 2, and in the ground state we have got nx and y, which is 1 1. 2 electrons can be in this state. Here 2 electron is in 1 2 state, 2 electrons are in 2 1 state. Okay, but they both have same energy where the value of n square will be 5. Okay, we have got 6 electrons. Now next, what is the next possible combination? So we have to take care of the
8.
combinations.
2 2.
8 होगा.
Like I can check 1 3, but 1 3 becomes actually 1 square plus 3 square, that becomes 10. But if I check 2 2 combination, that's 2 square plus 2 square, this becomes 8. So 2 2 is the next level because obviously 8 is lesser than 10 now. So n square is 8, and that's 2 2. So that's 2 2, and I have again 2 electrons. It's again non-degenerate. Nobody else can have 2 2. And then we have got n square equals to 1 3. That's next,
Yeah.
no? Or do we have another combination possible? 2 2 1 3. That's it. Okay. So we have n square equals to 10, which is 1 3 or 3 1 combination, people. 1 3 combination or 3 1 combination. But now we are left with only 1 electron now. 2 4 6 8. Total there are 9 electrons. Now I'm left with 1 electron. So 1 electron can be in either of the state. Doesn't matter. At the end they will have same energy. So it can be here, it can be here, it can be downspin, it can be downspin. But doesn't matter, 1 electron will be somewhere, it can have whatever speed, we don't care about it. That's it. So now you know the energy value of this. Final answer, total energy of this will be equal to n square pi square h square upon 2 ml square, and you know the value of n square already. Okay, so 2 electrons into n square is 2 pi square h square upon 2 ml square plus 2 electron. Sorry, now we have got 2 and 2. Now we have got 4 electrons. N square pi square h square upon 2 ml square. N square is 5 this time. Okay, so 5 pi square h square upon 2 ml square. I hope you are understanding. Then I have got 2 more electrons. n square pi square h square upon 2 ml square. N square is 8 this time. So 8 pi square h square upon 2 ml square. And then we have got 1 electron and n square is 10. So 1 electron and n square is 10 pi square h square upon 2 ml square. Are you with me, people?
Yes, sir.
Good. Please ask me if you have any questions. Do not hesitate. All the 11 of you who are present right now. If you are thinking, so what if they ask us the answer in terms of even? Because in numerical answer type, that is probably the case. It's okay, now find the total, divide by even. Okay. So what is the total answer right now? 2 2s are 4 plus 4 5s are 20 plus 8 2s are 16 plus 10 1s are 10. The whole upon that this into pi square h square upon 2 ml square. Correct? 2 2s are 4, 4 5s are 20, 2 8s are 16, and 1 10s are 10. So we have got 16 plus 10 26, 26 plus 20 46, 46 plus 4 50. We have got 50 pi square h square upon 2 ml square. This is total energy that you have got, like minimum energy, minimum possible energy that the state system can have. But what is energy of even? That's n square pi square h square upon 2 ml square. But remember, for the ground state, the value of n square is 2 this time. For ground state, the value of n square is 2. So like this is ground state, you can see ground, whatever, E ground. And this is actually 2 pi square h square upon 2 ml square. However, they denote it. So but total energy upon the ground energy, total energy upon the ground energy, which is equals to total energy is 50 pi square h square upon 2 ml square, the whole upon 2 pi square h square, the whole upon 2 ml square. So pi square h square 2 ml square, pi square h square 2 ml square gets cancelled. 50 by 2, this is 25. So total energy is 25 times the ground state energy, people. Any questions? Anyone? Anywhere?
Yes, sir.
Sure. Next. After this, we have got. So I think there is no point now in unnecessarily stretching this. You know what you are supposed to do when it comes to spinless fermions. Single, single, single. Okay. Like if I had spinless fermions, then I will have 1 electron here. I cannot have 2. Okay. Only 1. Then I will have 1 here, 1 here, 1 here. Suppose I would have given you 4 spinless electrons. Then 1 will be here, 1 will be here, 1 will be here, 1 will be here. 2 cannot be in same states basically. So this is how it works for spinless. Okay. If I had bosons, then all of them will be in the ground state. So that you already know. And now we can jump to 3D. In 3D also we don't need to stretch it. I think it's very similar, identical. Do you want me to go for 3D? You need to tell me now. 3D
No,
करेगा
sir.
sir? No.
No,
Because
sir,
it's very similar, no? Clear. Okay, so let's jump to harmonic oscillators. Next. So in harmonic oscillators also, actually harmonic oscillators are more easy, very easy comparatively to this boxes, because here the n square wala generate is not there finally. Okay. So first of all, when it comes to energy, like if we talk about 1D harmonic oscillator, then energy En is given by n plus half h cut omega. But now n can start from 0. That is the first difference. In harmonic oscillators, n can start from 0, because even if you substitute 0, energy does not become 0. And that was our Heisenberg's uncertainty principle ka rule. We cannot have 0 energy, people. That's what we had derived also. Okay. But anyway, so En, ground state E0. Now we can use E0. There, ground state was E1. Now we can use E0. So E0 is half h cut omega. Okay. When it comes to 2D, we have got ENX and NY. Achha, wait, let's first just take a simple question on 1D. So suppose again I have given you 5 electrons, maybe 5 electrons. Okay. And suppose along with 5 electrons, again, suppose I'm giving you 3 protons too. Okay. And I want us to find the minimum possible energy of this state. So what do we have? Remember, 1D is non-degenerate. Okay. N equals to 0, that's ground state. N equals to 1, first excited. N equals to 2, second excited. n equals to 0 ground state, n equals to 1 first excited state, n equals to 2 second excited state. Remember, when you have electrons and protons, you need to draw separate graphs, separate diagrams for them. Why do we do this? What is the reason that we do separate graphs, like separate diagrams?
Different masses.
Yes,
different
they have
masses.
different masses, so their energy will be different. Because energy, people, when you use the formula n square pi square h square upon 2 ml square, the mass value is different. Achha, by the way, I have a small question. I don't remember. What was? Oh, sorry. Here it's fine. Here, mass is not a factor. Mass was a factor in boxes.
In boxes.
In boxes. Here, mass is not a factor actually. Interesting. Now, this we are realizing today because we did not discuss this before. So here actually, okay. I mean, we can treat them separately initially, but mass is not a factor here. It is only a factor in boxes actually. Okay.
Total 8 electron लेके कर सकते हैं.
Basically yes, because both of them are fermions at the end. So you can directly understand, like instead of understanding 5 electrons and 3 protons, we can just say there are 8 fermions. No. But no. Actually, the thing is, electrons are electrons, protons are protons. They have got different masses. This is interesting actually. No, you cannot consider them as 8 electrons. The reason is, see, I can have in the ground state 2 electrons. I have 2 electrons and I have got 1 proton. 1 electron. Okay, 5 electrons are done. If you would have taken 8 electrons, what will happen here?
2.
हाँ ना, ऊपर चला जाएगा. You will have higher energies. No, so
Yes,
you will still have to. You still need to create 2 boxes. Interesting, but mass is not a factor. That's a thing to realize here. Nice. Okay, so we have got 3 protons. We have got 2 protons here and 1 is here. So that's the answer then. Our answer would be minimum energy. Minimum energy is 2 electrons are in ground state, 2 electrons are in first excited state, 1 electron is in second excited state. And we have got 2 protons in ground state and we have got 1 proton in first excited. Now the thing is, in boxes, people, this energy and this energy would be different because masses were different. So here you would have written, E naught dash and E1 dash, because protons will have different energy in boxes, but here they will have same energy. So here we will just write it. Okay, bas then. So whatever is the answer. Clear, people? Any questions, anyone? But actually, this becomes interesting. They should probably mention that omega of protons and electrons is the same, because like if I just use the spring ka concept, which is not valid here, but omega in springs, people, it is under root k by m actually. Omega becomes a function of mass in case of springs. Okay. Obviously, it's not, this logic is not valid here, but if they are giving you a kind of question like this, see, this was a very instinctive question that I took right now. But if they are giving you a question like this, then it is their responsibility to mention that electrons and protons have got same omega. And if they have different omega, then automatically E naught dash and E1 dash will be right, if they have different omega. Clear, everyone? Do you have any questions here?
No.
And now you can substitute now. You can find the values here. E naught will be 0 plus half h cut omega, E1 will be 1 plus half h cut omega, E2 will be 2 plus half h cut omega. Okay. E naught dash would be 0 plus half h cut omega dash. E1 dash would be 1 plus half h cut omega dash. If omega and omega dash are equal, then okay, whatever is the answer. But have you understood what I'm trying to convey here? Do you have
Yes,
any questions here? Okay, next. 2D harmonic oscillator. So now we have got ENX and ENY. So total energy you can write ENX and Y, and it's basically sum of these two. So that's NX plus half h cut omega plus NY plus half h cut omega. If actually we can also take one question on anisotropic harmonic oscillator, where if you remember, omega x and omega y will be different. Here right now I'm assuming that omega x and omega y are same, but technically I have omega x here, I have omega y here, and if this happens, if omega x and omega y are different, sorry, in that case you call it anisotropic harmonic oscillator, and if they are equal, then you call it isotropic harmonic oscillator. Okay, so this basically becomes nx plus ny, half plus half is 1 h cut omega, nx plus ny can be written as n, so this is n plus 1 h cut omega. Okay, so that's it. So what is n? N is nx plus ny, and now we can decide the order. Here people, even though technically nx is a different quantum number, ny is a different quantum number, but n automatically here becomes a quantum number. Why? Because it is addition of nx and ny, no? So n can take all the values 0, 1, 2, 3, 4, 5, 6. N can take all the values. In case of boxes, n couldn't take all the values because there it was n square was nx square plus ny square. So here you cannot have 0, 1, 2, 3, 4. Here you will have, like 1, 1 combination, then you are Siddha getting 1 and 2 combination. So n is 1, like I think if you take 1 and 1, n becomes root 2. So n is 1.414. You are getting a very weird value there. But here n automatically takes all the values. Just a minute. So here energy En, n can take all the possible values. Because even if you take 0, 0 combination, n becomes 0. Then if you take 0, 1 or 1, 0 combination, 0, 1 or 1, 0 combination, n becomes 1. So we have got multiple combinations possible. But n can be 0, n can be 1, n can be 2, n can be 3. Here n becomes a quantum number. In boxes, it is not a quantum number. Are you with me? Shall we?
Yes, sir.
Chalo. So let's take a random question on this. Maybe one last question related to this section now. So suppose again I'm giving you, let's say 6 electrons, okay? And let's work on this 2D harmonic oscillator. So what do we have? Right. Ground state. When n is 0, it means nx and ny both will be 0. Okay. So basically 0, 0 combination. 0, 0 combination. 2 electrons. Okay. Now, when n is 1, it means nx could be 0, ny could be 1, and x can be 1, and ny could be 0. We've got 1, 0 combination and 0, 1 combination. Both of them adds up to 1 now. nx plus ny. Remember, yeah, n is nx plus ny.
Yes, sir. Yes, sir.
Yes, sir. N plus 1 hota hai degeneracy.
Yes. So this is 2 electrons, and this is again we have got 2 electrons. We can proceed further. I can, maybe make it, let's say 12 electrons. Let's make it 12 electrons, just to recall a few more things. So n is 2. What is degeneracy?
3.
3.
Okay.
Three.
So now we have got 3 degeneracy here because one combination is 2, 2. Sorry. One combination is 2, 0. Another combination is 0, 2. Another combination is 1, 1. 1 plus 1 is 2. 0 plus 2 is 2. 2 plus 0 is 2. As you remember, actually it's a good way to remember that degeneracy is n plus 1 basically. So here 0 plus 1, 1 degeneracy. 1 plus 1, 2 degeneracy. 2 plus 1, 3 degeneracy. Then you have 4 degeneracy. Then you have 5 degeneracy. So directly we can write 2 more electrons, 2 more electrons, 2 more electrons. 12 electrons are done. That's it. So our answer would be, now you know what to do after this, okay? Okay? 2 in the ground state, then 4 in the first, and then 6 in the second. Okay? So this is 2 into ground state energy. Remember, please in here, do not use n plus half h cut omega. In 2D, it is n plus 1 h cut omega. Be very careful. Huh? In haste, you may end up using n plus half h cut omega. In 2D, it is n plus 1 h cut omega. Okay. So this is 0 plus 1 h cut omega, which is just 1 h cut omega. Plus 4 into 1 plus 1 h cut omega, which is 2 h cut omega. Plus 6 into 2 plus 1 h cut omega, which is 3 h cut omega. So our answer is 18 plus 8 plus 2. That's 28 h cut omega. Clear?
Yes, sir.
Okay. And similarly, we have 3D too, so we don't need to do 3D. Very identical. We can take one question on anisotropic and then we will wind this up. Anisotropics related. Suppose I am giving you potential energy X, Y, Z. Okay, and they have given us. It is given by, let us say, I'm thinking. Just a minute. Half m omega square x square, no? Okay. So suppose it's 0. No, let me think. Okay, 0.5 m omega square x square plus 4.5 m omega square y square plus 32 m omega square z square. Okay, they have given you this, and they are asking you to find energy of 1 to 1 state. Energy of this they are asking you. Okay, how to do this?
सर कंपेयर करेंगे.
Yes, सबसे पहले we will write this as half m omega square x square. This is half m omega x square. Okay, anisotropic oscillator. Half m omega square y square, but we will write this as half m omega y square, and this becomes half m omega square z square, but this becomes half m omega z square. Okay, so if we compare people, okay, gets cancelled, x square gets cancelled. You can say 0.5 omega square is half omega x square. Okay, half omega x square, this is 0.5 omega square. Similarly, half omega y square, this is 4.5 omega square, and similarly half omega z square, this is 32 omega square. I hope you have understood this.
Yes, sir.
Okay, half omega x square, that's 0.5 omega square, half omega y square, that's 4.5 omega square, half omega z square, that's 32 omega square, by comparing people. So omega x square, half and 0.5 gets cancelled, is omega square. Matlab omega x is omega. Next, okay, half goes on that side. Omega y square is 9 omega square. It means omega y is 3 omega people. Okay, omega z square becomes 64 omega square. It means omega z is 8 omega. That's it. We have got omega x, omega y, and omega z. Omega, 3 omega, and 8 omega. Any questions?
No, sir.
Okay. So omega x is omega y is 3 omega, and omega z is 8 omega. So total energy is basically nx plus half h cut omega x plus ny plus half h cut omega y plus nz plus half h cut omega z. And what do we have? 1 to 1. So substitute now. 1 plus half, that's 3/2 h cut omega x, which is omega, plus we want to calculate, remember, 1 to 1. No? So I substituted 1. Now substitute 2 people. So 2 plus half, that's 5/2 h cut into what is omega y? 3 omega, plus substitute 1 plus half, that's 3/2 h cut, what is omega z? 8 omega. So our answer is 3 plus 5 3s are 15 plus 8 3s are 24 h cut omega by 2. So this would be 24, 15, which is 39, plus 3, which is 42, 42/2, which is 21 h cut omega. All good, everyone.
Yes, sir.
Okay. So this is it. Let's not waste time then. We'll just stop here. I think this is what you wanted me to cover. Anything else you want me to cover in model, you can tell me now, otherwise.
सर हाइड्रोजन एटम से कैसे मतलब क्वेश्चन आ सकते हैं?
Hydrogen atom, but like which part? Like the one that we learned in.
तो सर आपने सर मॉडर्न फिजिक्स में लास्ट में कराया था.
अच्छा, last में the one that we took now.
Yes, sir.
Okay. See, Max, I have asked you to by heart the ground state wave function. Okay. So mostly they can ask you probability around that. They can give what is the probability of finding this ground state from this region to this region, something like that. Okay. Or there could be average position x, average x square, and I think they have calculated x and x square. That should be it. And what else? We took one question on hydrogen atom. I think so, where we calculated average energy too. Not sure. But okay, I mean, whatever it will be the kind of questions that we have covered in the class. So don't scratch your head zyada uspe. But just remember by heart the ground state energy of hydrogen atom. That's important. And one question that could be asked is they can give you a hydrogen atom ka wave function and they can ask you quantum numbers, the value of n, l, and m. I hope you remember how do we compare and find. If you remember, we have done this in the class where I don't remember exactly what we have written, but something like this. We had r, theta, and phi, and we had divided this as r of r, and then we had theta of theta, and then we had phi of phi. This was r, theta, and phi. This was wave function of hydrogen atom, and we have written how r depends on quantum numbers, how theta depends on quantum numbers, and how phi depends on quantum numbers. So what maximum I think would happen here is they can give you an equation, and from that they may ask you to identify the quantum. Understanding what I'm trying to say here? Rita, you're
Yes, sir.
confused? Or
Yes,
wait,
sir.
I can create a random question on this. Hello.
Yes, sir. Please do one question.
ठीक है. On quantum numbers पे I can just create. I just need those equations, but just a minute. Okay, so for an example, we have written, if you see in the book, that R depends on N and L, two quantum numbers, and it is given by e raised to some random constant. I think we have written A R upon N, and then we have written R raised to L, and then there is some function of R, Similarly, we have written, see, this is extreme level question I'm speaking about, only because you said कि hydrogen atom पे what kind of questions they can create. So then theta of theta, it is sine raised to mod of ml. We have written, and then there is theta, and then there is a function of theta. Okay, and then there is phi raised, which is a function of phi, and it is given by e raised to I ml phi. Okay? So for an example, I can create a very good question, something like this. Suppose I'm giving you that a wave function is given by, let's say, e raised to minus, thinking just a minute. Is to L, this L minus 1. Okay. No, suppose I'm just giving you, it is just e raised to I, or let's say e raised to just minus 2I phi. And I'm asking you that which of the following is definitely a principal quantum number, and you have been given some options. Let's say or wait, suppose this wave function is given to you right now. What can I identify from this? So this can be compared. This has a phi, no? This has phi. So this can be compared with e raised to I ml phi. So if you compare, what do you have? You have value of ml. Ml is minus 2. Is this a logical value of ml? It is a logical value of ml. Where do we see minus 2 usually? So we can have minus 2, minus 1, 0, 1, 2. Correct? This is minus L to L. Hai? If ml is minus 2, what are the possible values that ml can take? Minus L to L. Do you remember this?
Yes, sir.
So basically n becomes what? That's it, L plus 1, like you said. So it will be 2 plus 1 and it will be 3. So they can ask you, so what is the short value of n? N can be definitely 3. However, remember, it could be 4. This is the minimum value of n. So they can ask you what is the minimum value of n. Because see, if ml is minus 2, there is also a possibility then you can have minus 3, minus 2, minus 1, 0, 1, 2, 3. So here it is going from minus L to L, but in that case L becomes 3, n becomes what? 3 plus 1, n becomes 4 actually here. But they will ask you what is the minimum value of n. But this is an extreme level question which I am thinking could be created. But I hope you understood this. So this is the largest thing I could think of. Please tell me, people, if you need explanation for this. All of you, have you understood this? See, it's simple.
Yes, sir.
In exam now, if I give you n is 3, L can take values, you need to remember, from 0 to n minus 1. Okay? So n, it can take values from 0 to 3 minus 1. So it can take values from 0 to 2. It means L can take 0, L can take 1, and L can take 2. And now there are many combinations possible. So 0, when it is 0, when L is 0, then one possibility is when L is 1, and then one possibility is when L is 2. There are 3 possibilities of L. You know? ML can take minus L to L. Okay, ML can take minus L to L, and ML can take minus L to L. Okay, so here it will take minus 0 to 0, which is 0. Here it will take minus 1 to 1, it means minus 1, 0 and 1. And here it will take minus 2 to 2, it means minus 2, minus 1, 0, 1 and 2. So what are possible wave functions? When n is 3, L is 0, ML is 0. One possible wave function is 3, 0, 0. Another possible wave function is when n is 3, L is 1, but ML is minus 1. 3, 1 and minus 1. Then 3, 1 and 0. And then 3, 1 and 1. 3, 1 and 0. 3, 1 and 1. This is degenerate. Okay. They all have same value of n people. Actually, all of them are degenerate right now. Then we have got another possibility where 3, 2 and minus 2, 3, 2 and minus 1, 3, 2 and 0, 3, 2 and 1, and 3, 2 and 2. We have got 3, 2 minus 1, 3, 2 minus 2, 3, 2 minus 1, then 3, 2, 0, then 3, 2, 1, and then 3, 2, 2 people. So how many degeneracy do we have? One question could be find the degeneracy of hydrogen atom. So what is the degeneracy people here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Degeneracy in this case is 9. Actually, there is a shortcut formula n square if you remember. Degeneracy of hydrogen atom is n square. Provided you are ignoring spin. If spin is also included, then you will have 2n square. I hope you remember that too.
Yes, sir, double हो जाएगा.
Because you can have upspin, you can have downspin. Upspin, downspin. Upspin, downspin. So double हो जाएगा, you will get 2n square. So that could be it. Mostly degeneracy question could be created, a nice question. Okay, everyone.
Okay, sir.
Okay.